A relation in mathematics is a way for us to pair inputs with outputs. So imagine that we have some equation and we're going to put some numbers into that equation and then it's going to spit out some other number. And that's going to be our relation. So we have some input values, we call that the domain, that's our set of x values on the x-axis. And then we have the output values, we call that the range, that's the y values on the y-axis, the up and down axis. So we've got a table of values here, so 2, 2, 3, 1, 2, 5, and 5, 6. We're going to plot these points and see if this is a specific type of relation called a function. So a function is a specific type of relation where every input has one and only one output. So with x value of 2, we've got a y value of 2. Let's plot that point. That's right here. Then we've got an x value of 3. With a y value of 1, we'll plot that one. And then an x value of 2 with a y value of 5. Then there's an x value of 5 with an output, a y value of 6. So there's 4 points there, and we're going to have to determine whether or not this is a function. Well, this is not a function. And the reason is, right here on the x value of 2, there's 2 outputs for that one input. So when we put in an x value of 2, we could get 2 and we could get 5. There's 2 y values for that one input. So this is not a function. If we look at the next one, here we've got 2, 4, 3, 1, 5, 3, and then 4, 6. Now if you look at this one, every input, every x value only has one output. There's no place where you have an x value that has 2 y values. So this is a function. I'm going to go back to the last example and we're going to look at doing a mapping diagram. So what this is we're going to just list the x values, list the domain, list the range, the y values, and then we're going to draw arrows going from each x value to its corresponding y value. So the x values for this one are 2, 3, and 5. Notice that 2 is here twice, so I'll only list it once here. Then the y values are 1, 2, 5, and 6. Okay, an x value of 2, well, that goes to 2 because of this pair, and it also goes to 5 because of this pair. If we look at a y value, an x value of 3, that's going to go up here to 1 because of this pair. And then 5 goes to 6. So there's the mapping diagram. And you can see that the input 2 has 2 different outputs. It goes to 2 and it goes to 5. So that's what makes this not a function. Whereas if we look over at the second example and start doing a mapping diagram, x values are 2, 3, 4, and 5. Y values are 1, 3, 4, and 6. If we start drawing the arrows, 2 goes to 4, 3 goes to 1, 5 goes to 3, and 4 goes to 6. So you'll notice that each input, 2, 3, 4, and 5, only go to one output. There's only one value that is associated with that, one y value that's associated with that. So that is a function. Let's start graphing. So you may know how to graph something in slope-intercept form already, but let's look at graphing it just by using some points. So maybe we'll draw a table here, and we could plug in, say, 0 for x. If we plug in 0 for x, we're going to get 2 times 0 plus 1 for the y value. Well, that's just going to be 1. 2 times 0 is 0, plus 1 is 1. So we could plot that point. And I'm doing this because I want to remind you guys that if you don't know how to graph something, you can always just start plugging in some random numbers and see what you get. Alright, let's maybe plug in 2. If we plug in 2, we're going to get y equals 2 times 2 plus 1. Well, 2 times 2 is 4, plus 1 is 5. And we could keep doing this, we could keep plugging more and more numbers in, but it would all kind of fall on this same line right here. So since this is a straight line, we can just take those 2 points and draw a straight line between them. Now the question is this a function? Well, if we look at every x value, there is only one y value for this line. So every x value, if we go to an x value of 2, that's going to have a y value of 5, x value of 0 has a y value of 1. We look at any x value on here, it only goes to one y value. So yes, this is a function. If we want to determine graphically whether or not it's a function, we can use something called the vertical line test, which basically means we're just going to start drawing vertical lines anywhere we want. And we should, if it is a function, we should be able to draw a vertical line anywhere on the graph, and it should only hit the graph once and only once. So we use the vertical line test. So this one passes the vertical line test. So it is a function. To give you an example of something that is not a function, something that would fail the vertical line test, we could use something like a circle. So if we were to graph a circle on here, and then if we were to start trying to draw vertical lines through this circle, well, you'll notice here, it hits here, and here, there's 2 points on the circle where it hits. So for this x value of -2, we get 2 different y values, and this fails the vertical line test a whole bunch of times, no matter where in that circle. I mean, unless we draw one right here where it's tangent, it just touches the circle. Every other point, aside from the other side, is going to hit that circle twice. So that one fails the vertical line test. One other thing about graphs, if you see in your book the words independent variable and dependent variable, the independent variable is the x values, the dependent variable is the y values. This comes from science. If you're doing an experiment where you're trying to control one variable, you're trying to change one thing in your experiment to see how it affects something else. The independent variable is the one that you change, and then the dependent variable, the y value, that's the one that changes depending on how you change the independent variable. So independent is x, dependent is y. I'm going to introduce to you a new notation for writing functions. So when we have something like a straight line, or other types of objects that we'll talk about later in the class, we can, instead of writing y equals something, like this one, we can rewrite this as function, in function notation, as long as it is actually a function. And so what we do for that is this thing right here, this f with the parentheses and the x. Now, it's important to remember that this is not variables. So, well, the x is a variable, but the f is not a variable. This is not f times x, as you might have variables being multiplied by each other. This f stands for function. So what this means when we write the f, that says, all right, we have a function here, and that function is going to use the variable that we put in parentheses. So when we write f parentheses x and then end the parentheses, that's saying we have a function after the equal sign, and that function that's after the equal sign uses the variable x. That's what that thing says. So we're saying this function that uses x is equal to, and then in this case, 3x minus 4. So the function is 3x minus 4. The f tells us it's a function. The thing in the parentheses tells us what the variable we're using is. And we say this f of x, a function of x, meaning it's a function that uses x as the variable. In this class, you can think of f of x as just being y. So this is, for the purpose of this class, is no different than just y equals 3x minus 4. When you get into later math classes, you can have functions that have more than one variable. So we could use, say, a function that uses both x and y, and we could say something like x squared plus 2y minus 3 or something like that. But we're not going to do that in this class. You don't need to worry about that. But for the purposes of this class, f of x, you can think of that as just being y, just your y values. One of the advantages of function notation is we can I can very simply tell you to plug something into a function. So if I tell you that f of x is 3x minus 4, and then I say find this, f with the parentheses 2, that means find f of 2. It means take 2 and plug it in for x. So what we would do is we would take our 3x minus 4 and rewrite it, but instead of writing x, we're going to write 2. We're going to plug 2 into the function. 3 times 2 is 6. Minus 4 gives us 2. So what this tells us is that f of 2 is 2. So we plugged in 2 for x, and then when we worked that out, we got 2 for y. So this right here is equivalent to saying we have a coordinate point 2, comma 2. Plug in 2 for x, we get 2 for y. We plug in, if we say f of negative 4, we're going to plug in negative 4 for x. So f of negative 4 equals 3 times x, except that x is negative 4, minus 4. 3 times negative 4 is negative 12. Minus 4 gives us negative 16. So we can say then that f of negative 4, so the function, the value of the function at negative 4, the y value, is negative 16. Again, that is equivalent to saying that there is a coordinate point where negative 4 is the x value and negative 16 is the y value. Those are the same thing. So f of negative 4 equals negative 16 tells you there's a coordinate point with the x value of negative 4 and a y value of negative 16. Find f of 0, we'll do one more of these. So we're going to take the function 3 times x minus 4, but we're going to plug 0 in for x. So 3 times 0 is 0, minus 4 is negative 4. So that means that f of 0 is negative 4. Again, that tells us that there's a coordinate point with an x value of 0 and a y value of negative 4.